Hello everybody, welcome into another lesson. So today we are going to talk about the greatest common factor of monomials. So in basic math, and I know in pre-algebra, we did the greatest common factor of numbers, of constants. Now we're going to deal with monomials. So it works the same way, the only thing is there's variables involved. First thing I would do, take your constants, take your 48 and 72, or your coefficients, excuse me. Take your coefficients of each expression. We have 48a squared b c cubed, then we have 72a b cubed c squared. I would look at your 48 and 72 first. What is the greatest common factor of 48 and 72? That's going to be 24, because 24 goes into each of them. Alright, we have established that. Now let's look at each variable at a time. First term has a squared, second term has a. Well, the greatest common factor for a and a squared is just a. They only have a common a between them. And then let's look at b. You have b on the first term, and then you have b cubed on the second term. They only have a b in common. And then you look at the c's, you have a c cubed and a c squared. The highest c power they have is c squared. So basically with the variables, you're going to take the highest, whichever one has the lowest power, whichever one has the lower power of that variable, that's your greatest common factor of the variables. So for the first one, between a squared and a, the a is lower, so that's your greatest common factor of a. Then between b and b cubed, well, b is your lower power, so b is your greatest common factor of those two. And then between c cubed and c squared is your lower power, so c squared is your greatest common factor of those two. So the answer you should get for the greatest common factor would be 24abc squared. This is leading into factoring of polynomials, so this is why we are doing this today. It's important first to be able to factor them just as the numbers separately. Alright, let's see. We have 36 x squared, y squared, z squared. And then we have 24x y squared z cubed. Alright. So again, first start with your coefficients of 36 and 24. What's the greatest common factor of those two? Of 36 and 24, that'd be 12. 12 is the highest common factor that goes into 36 and 24. So we got the 12. Now between x squared and x, what's your greatest common factor? Your x to the first is your lower power, so that's your greatest common factor, would be x. Then you got your y squared and y squared. Well, they both have the same power, so y squared would be your greatest common factor. Then between z squared and z cubed, well, the z squared is your lower power, so that would be your greatest common factor of z squared and z cubed. So the answer to this would be your greatest common factor is 12xy squared z squared. All right. We got 25 p squared q cubed. We have 15 p squared q squared. Then we have 35 p q to the fourth. So now we have three terms we have to consider. We got to find the greatest common factor of these three terms. Well, once again, start with your coefficients of 25, 15, and 35. What's the greatest common factor 25, 15, and 35 have in common? They have a 5. Alright, so they got 5 in common as their greatest common factor. Now between p squared, and p, what's your greatest common factor? Well, p is the lowest power, so that would be your greatest common factor of the p's. Then you have q cubed, q squared, and q to the fourth. What is your greatest common factor of those? Q squared is your lowest power, so that would be your greatest common factor of the q's. So in total, the greatest common factor of these three would be 5pq squared. Alright, we have 56 r to the fourth, s to the third, 28 r to the third, s to the second. Then we have 42 r to the third, s. Alright. So, we got to look here. We got to look at what, let's start with our coefficients, 56, 28, and 42. What is the greatest common factor of 56, 28, and 42? The greatest common factor of those numbers would be 14. That's the greatest common factor. Now, we look at our r terms. We have r to the fourth, r to the third, and r to the third. What's the greatest common factor of the r's? The lowest power is to the third, so it would be r to the third. Now we have the s's. We have s to the third, s to the second, and just s. Well, s is the lowest power, so that would be your greatest common factor of the s's. So in total, you should get 14 r cubed s for your greatest common factor of these three numbers, of these three monomials, rather. Alright, got a couple more. This is not going to be a super long lesson. We have the quantity of x plus y times x minus y. Then we have 2x times the quantity of x plus y. Alright. Let's look for what they both have in common. They both have an x plus y in common. Do they have anything else? They don't have an x minus y in common. They don't have an x term in common. So literally the only thing those two terms have in common is going to be x plus y. That's literally all they have in common, would be x plus y. Alright, one more problem. Probably a good thing I'm finishing up because we have a storm coming in. This one could be a bit of a doozy. We got 4p squared times the quantity of p minus 1. Then we have 6p times the quantity of p plus 1 squared. Okay. Let's look for what these terms have in common. start with your coefficients, your 4 and your 6. What's the greatest common factor of 4 and 6? That'd be 2. So we got the coefficients. Now let's look at just the p terms. We have p squared and p. Well, p is your lower power, so p would be common. Now then you have also p minus 1. Do you see a p minus 1 in the second term? You do not, so there's no greatest common factor for that. The second term has a p plus 1 squared. Do we see a p plus 1 in the first term? We don't. So therefore, all you're going to get for your greatest common factor is 2p. That's all you would get, 2p. So really, finding the greatest common factor of monomials is a lot like finding it of numbers, only you take each piece at a time. Start with your coefficient, find the greatest common factor of those. Then you take your variables, and if you have parentheses with a sum or difference, that's considered its own multiple. So the p squared is different from p minus 1. Those are different. So you take those piece by piece. Just take it piece by piece and you build your greatest common factor. I like the piece method. That's the best way to do it. So that's it for this lesson. Next lesson we are going to divide polynomials by monomials. I hope everyone has a good day. Take care.